Hey guys, and welcome back to a new video. In this video, I will show you how you should manage your different dependencies in a multi-module project. And this will actually be part one of this little multi-module series. In this first part, as I said, I will show you how I recommend you to manage your dependencies. And in the next part, I will show you how you can build a custom Gradle plugin in order to also manage your shared Gradle config in a multi-module project. Right away, what these videos won't be about is what a multi-module architecture is, how you can use that to speed up your Gradle build, how you should structure a multi-module project, which benefits that has, and how you just build a real application around that. Because for that, I already have a very extensive premium course on my website. So if you say you enjoy these videos here and you want to learn more about a multi-module architecture to really make your application scale, then get the course, first link in this video's description. So the first thing I want to do is I want to show you the problem we normally have with a multi-module architecture when it comes to managing dependencies. So let's just create some submodules here. First of all, let's switch to the project view, minimize this, open this, and then right-click on our project to create a new Gradle module. And here we'll just select Android library. So a module is really nothing else than just a library which is directly embedded in your project. And an Android library is just a library that can access the Android SDK. Let's just call this books data source, for example. Let's say we have a books list application where we can fetch books from a remote data source, save that in our local database. And the data source for that, so the remote data source and the local data source, could just be put in such a module here, which is called books data source. The rest can stay like that. Minimum SDK 24 looks good. Make sure you're using Kotlin DSL, so the Kotlin version of Gradle, and then click finish. And after Gradle synced here, you can see there's a books data source module with a little blue icon now. And we also now want to create an additional module just to demonstrate what I want to show here. So new module, Android library, and this could be the UI for a books list. So books-UI, finish, wait until Gradle synchronized, and this is recognized as a module. If we now take a look here in these modules, you'll notice that both these, of course, have their own Gradle file, because you could now take these modules, extract them out of this code base and introduce them in an additional code base. And that new code base where you would reuse these modules would of course also need to know the config of each single module. So that is why each module has its own Gradle file, since each module is also treated as an isolated Gradle unit. So it's built separately. That means the build is also sped up when you implement it correctly. If you do it wrong, then it will strongly backfire later. But I teach all that in my course. But if we take a look in here, it's really nothing else than our app level build.gradle file which we find in our app module. Right here, the only difference is that here we have the application plugin and here we have the library plugin. And the first problem you'll notice is, if you scroll down to the dependencies, all these are at the moment just specified separately. So we don't really have a global place where we manage these dependencies and how we can now take a specific dependency or set of dependencies and include them in a module. Because on a larger scale, you won't have just two modules of your app, but very likely a lot of these. And then it's also very likely that if you have your retrofit dependency here, for example, implementation, blah, blah, retrofit or so, and the same for room, then it's very likely that this books data source module is not going to be the only module which requires these dependencies. No, other modules might need these as well. And if you now hardcode these like that and like these here in every single module, and then you want to update a version of a dependency, then you will find yourself going through every single module and updating the version here correspondingly. Also, we want to avoid that we always need to copy paste dependencies because we can't remember these strings for obvious reasons. So that is the problem I want to solve in the first video here. In the next video, I will then show you how we can build a custom Gradle plugin, which can be used to share this common config between modules. So these compile options, then for example, the namespace, the default config block here, minimum SDK, compile SDK, all these kinds of things which you don't want to specify separately for each module, but rather once and for all in a Gradle plugin. So what do we need to start managing our dependencies better? Let's remove that here. We need a so-called build source module. Build source is a reserved name from Gradle, which is its own module, but this module is really only used to contain Gradle specific code. So that won't be a module we will include in our production code and call functions from that module in our production code. No, that will only contain build-specific logic. And to create that module, we can go to a root package, right-click, new directory in this case, because we won't be able to create it as a module since build source is a reserved name. So directory called build source. Make sure to spell it exactly like this. And then in here, we want to create a file. On the one hand, git ignore to specify what we want to ignore in Git. In this build source directory, on the one hand, our Gradle cache directory and the generated build directory. And what we need is another file. Another file, build.gradle KTS, because this build source module also contains its own Gradle file. And to recognize it as such, we want to introduce this plugins block and add this Kotlin-DSL plugin. If we now synchronize this, then after a moment, you will notice something interesting. And that is that this little blue square appeared next to the module icon. So now build source is correctly recognized as our build-specific module. And we can now create a new folder in here, source main Kotlin, because that will be the folder in which we can now put our Kotlin classes, which contain our build-specific logic. And since we're using the Kotlin version of Gradle, this will really look exactly the same as if we were to write a normal function in Kotlin in our code base. And the cool thing about this build source module is now that all the classes we put in this Kotlin folder can now be accessed from the Gradle files in our whole project. So that means what we can now do is we can create a Kotlin object in this build source module, which I will just paste here because I don't want to write all the versions by hand. We can create a Kotlin object which contains our project versions. So just normal Kotlin constants for the compose version, compose material 3 version, compiler, hild, OKHTP, retrofit, room. So just the sample dependencies we would want to use for this project, for a data source and for the UI, of course. And now we have a central place where our versions are managed. And since all of our Gradle files, all of the Gradle files of the modules of our app will now access this object here and the versions in it, so we can just change these at a central place. So you can just copy paste this file from the GitHub repository down below, as well as the next file I will paste, which contains the dependencies. So I'll paste it here. You can see another object, and this is just now a file with constants for every single dependency we might want to use in this project. So we have compose, and you'll notice that this just refers to the versions of our versions file, and the compose compiler one isn't actually needed. But the other ones are, so our hild specific dependencies, the hild Android Gradle plugin, the OKHTP, logging interceptor, retrofit, Moshi, and room. So now with this file, what our modules would already be able to do is if we go to our books data source, for example, and open the build.gradle KTS here, what we could do now is we could say implementation dependencies.room KTX. And that is how we would add the room KTX dependency to this module. We would also need to do this for room runtime and room compiler. This one would actually be a capped dependency. But that way we can already add dependencies without needing to copy paste these strings anymore. And also, since all of our modules would refer to these constants, we can update the versions of our dependencies for all modules at a central place. However, that is still not ideal, because we always need to bundle so many dependencies for a single library, like for room. Retrofit requires multiple dependencies, so Moshi, OKHTP, the interceptor, these kinds of things. So we want a better way, an even simpler way to add our dependencies. And what we want to do for that is we want to go to our build source module in the build.gradle KTS file and paste this code, which you again find down below, or you just quickly write it off. So here in this build source Gradle file, we can now specify that we want to access the Gradle plugin, the Kotlin Gradle plugin, and the Android build tools. So we just have access to Android build specific functionality in our build source module. So Android build tool specific functionality would, for example, be, if we take a look in the module, here, this Android block. That's obviously a Gradle extension we only have in Android projects. And in order to find this and get access to that in our build source module, we need to add these dependencies right here. So here we have a global place where we manage our Kotlin version of the project, and this is the version of the Android Gradle plugin. Sadly, we can't access the versions file here in build source, since this would be a kind of a circular dependency. So yeah, you just need to change the Kotlin version here and the AGP version as well, but all other versions can be managed here in this versions file. So if we now synchronize this, and hopefully that will succeed. No, okay, I'll see why. So you can see the request for this plugin could not be satisfied. The issue is that we don't want to declare these plugins here twice, because we already declared the Gradle plugin and Kotlin. So here in our build.gradle project level file, we can just remove this complete plugins block. And the only Gradle plugin we need to apply is the one for Dagger Hilt, which I will also just quickly paste here. So you can see build script repositories, just where we try to look for these plugins. And then in our dependencies block, we add the class path to our dependencies Hilt Android Gradle plugin dependency. So you can see this is just what this will add with our specific Hilt version. If we try this again, we should hopefully now see a succeeding build. Yes, that's looking good. So what I now want to do next. If you remember, the problem was we don't want to declare every single dependency individually. For example, we don't want to add 3 dependencies for Hilt in every single module that uses Hilt. No, we just want to have a single one that bundles these. And for that, we want to go to our build source, Kotlin, and create a class called Dependency Handler extension. That is actually just a file which contains extension functions to Dependency Handler. So function, Dependency Handler, this one here, and that implementation. And this will take in a dependency. And what this dependency handler is now for. If we take a look in some kind of a module, for example, in data source again, and scroll down to our dependencies block, then here we get this dependency handler scope. So inside of the scope, we can call our implementation function now, which is here in dependency handler extension, which is just a nicer way to implement a specific dependency. So let me just write this and then I will explain it in a moment. Here we want to call add implementation with our dependency. Because for this dependency handler, there is not a direct way to call implementation with a specific dependency. To add that dependency, we actually need to call this add function with the specific configuration name, which would be implementation in this case. This could also be test or Android test. This could also be something like capped. So basically what comes before a dependency. And we just now create a bunch of helper functions to easily be able to then bundle these dependencies that we want to add to our modules. So let's copy this, paste this here a few times for all the kind of configuration names we might need. For example, for test, then Android test. We might need debug implementation for a composed dependency, debug implementation, and we need capped or KSP, whatever you like to use. And now let's see what we can do with these helper functions. We can now go to our dependencies file, and in here, I now want to bundle all the dependencies that belong together, because we don't really want to add just the Room runtime dependency to a module, but not the other two. No. When we want to add Room, then we want to add all these dependencies. So what we can do is we can have another extension function for dependency handler, which simply adds our Room library. And in here, we can now call implementation. So the function we just created, implementation. I'm not sure why it can't access that. Okay, it seems like just the autocomplete doesn't seem to work. But here we can pass a dependency. And now we can just refer to dependencies, Room runtime, duplicate this. We have Room KTX and Room compiler. And this one needs to be a cap dependency. And these helper functions are just necessary because these functions don't exist by default, but we would rather need to call add every single time and specify the configuration with a string, which is not so nice. So I just create these helper functions. And now the cool thing with this is we can go to our data source module, open the build.gradle file, and if we now want to add all the Room dependencies to this file, we just say Room. And that's it. That's how we add the dependencies to this module. So with this, you have a much easier way of managing your dependencies for a multi-module project. Let's also do this for the remaining dependencies. So we copy this, paste this for retrofit, paste this for compose, and what's missing, paste this for hilt. So retrofit, here we add retrofit, Moshi, OKHTTP, and the logging interceptor, and remove this. Then we have compose, which needs a lot of dependencies. Compose UI, compose UI graphics, compose UI tooling, compose UI tooling preview, which is a debug implementation. Then we need compose material and anything else, runtime, tooling preview. So we have 6 dependencies in total, and here I have 5, so runtime is missing. Oops, duplicate this. Oops, what am I doing? No, okay. This needs to be compose runtime. And last but not least, we use hilt. Dependencies hilt Android. This can be removed, and this one will be the hilt Android Gradle plugin, which needs to be applied with capt. Actually, not the Android Gradle plugin. This needs to be the hilt compiler, like this. And now we have all these dependencies that belong together bundled in these function calls. So if we now go to our data source, a build.gradle file again, we can remove all the dependencies we don't need here and just include those we do. So retrofit and hilt, since hilt needs to be applied in all Android modules if you want to use that in a multi-module project. And the same way, we can now go ahead and go into our books UI module, scroll down, remove all this code. We might need this here in the UI module. So normally I would also extract these app compat dependencies here out of this module, maybe the core KTX. So everything you need in this module, let's just leave this here and rather add what we need. And those are all of our compose dependencies and the hilt one. So you can see how easy that now is to add a set of dependencies to a module. For these modules, we also need to apply the hilt Gradle plugin and capt in order to make this work. So let's say Kotlin cap for now. And what is this? Dagger.hilt Android plugin. This will be made easier when you watch the next video. Then I will show you a way to also share this. But for now, let's add it like this. Also in data source. And also in our application module. So in app build.gradle KTS, add these 2 plugins, scroll down. Here we can get rid of all the compose dependencies, which we already add with our little function we created. The testing one I did not add, so let's keep this. And yes, I would say that looks fine. In here, we now want to add all of our dependencies, since that's typically what you want for your app module. This simply adds all the dependencies and all the Gradle modules to introduce. So retrofit, room, hilt, and compose. And as I said, this also needs to introduce the single modules of our app. Since if you put code in such a module here in source, then this code can only be accessed if the module is introduced in the Gradle file. And the way to introduce this works a bit differently than just adding a string. We need a different way for that by going to our dependency handler, copying the first helper function, pasting it here, and here we just want to make this dependency of the type dependency from Gradle artifacts, because that way we can also create helper functions for our modules. So let's copy this, paste it here. And in order to introduce our books data source module, we want to now add an implementation of project. That is how we add a project module in another module. And here we can now pass in the string. So that will be colon books dash data source. That is how you introduce a module in another module. I think I have the wrong import here, so let's take a look again. We need this one that takes in a string, and then it will work. Copy this for our books UI, and have this one here as well. Then we can go to our build.gradle app and add these modules down here. So books UI to introduce the books UI classes in our app module, and books data source. If we now synchronize this, we should hopefully not get any sync errors. No, that is looking good. Something that could happen here is that we get an issue with our JDK version, and Studio likes to complain about that recently, because here we're using 1.8. Let's just try to launch this on our device, and then we will see if it complains about an invalid JDK or not. Yes, it does. So you can see current target is 1.8. And here for this task, the current target is 17. So what I want to do is I want to upgrade the JDK version of the whole project to 18. We can do this here by just making this version 18, this 18 here, Kotlin options, JVM target 18. And again, in the next video, I will show you how you can also apply this for the whole project at a central place. But for now, let's keep it like that. And then in each Gradle module here for the books data source, make sure to also change this. And last but not least, in books UI, change this as well. And then synchronized, oh no, not synchronized it yet. We want to open the Android Studio settings, so preferences, search for Gradle, or I think it's under here. No, let's just search for Gradle. Here under Gradle, make sure that the Gradle JDK is 18. And then click OK. You of course need to have this JDK installed. Click synchronize now, and then you can run this, and hopefully now it compiles and builds. Okay, it still fails because the compiler version of Compose doesn't match with the Kotlin version. Let's downgrade our Kotlin version in that case. Go to versions. We can luckily now do that at a central place. Oh, actually not the Kotlin version. For that, we need to go to the build.gradle file, update this to 1.8.10. And if I now run this, hopefully we don't get any issues anymore. Yes, the app is launching. Everything is building. That is looking good. One last thing I want to just show you that everything works, obviously, because we now introduced our dependencies here in our app module. So we should be able to have access to retrofit, room, hilt, and compose here in our app module, which you can easily check by going to main activity and seeing if we have access to compose. That's looking good. We don't get any errors, but also retrofit. Yes, so our setup is working fine. So that was part one. As I said, in the next video, you will then learn how you can also get rid of all that shared configuration for your single Gradle modules. And you'll learn how you can create your very own Gradle plugin and apply it in your modules. And this will also be a bit simpler than what we did in this video, because here we also needed to have all that set up. So if this sounds interesting to you and you want to learn much more about a multi-module architecture, definitely get the course down below. You'll build a calorie tracker app in this course with a multi-module architecture. You will learn how you really come up with such a structure, because this is really just a sample. I wouldn't create the modules like this. And you will especially learn when you should absolutely not use a multi-module architecture, since you can do a lot wrong with that. So if it sounds good, get the course. And other than that, I wish you an amazing rest of your week. See you back in the next video about building your own Gradle plugin. Bye bye.